there is an element of which last electron goes, we can see is its last electron is showing that it will go into the 4s squared, but in real life it doesn't actually happen. The last electron goes from the 3d6. So how it is filling? The thing is, when the iron 26 electrons are filling, it first fills 1s square, 2s square, 2p6, 3s square, 3p6, and after filling out 3p6, it doesn't fill out 3d6, it fills out 4s square before 3d6. It fills out 4s squared before 3d6. And also, while becoming an ion, let's say when the Fe2 plus, or when it is becoming Fe3 plus, okay, what it does is it loses its 4s squared electron first, then 3d6. The thing is, between 4s squared and 3d6, while filling out, it always fills up 4s squared first and then 3d6. Also, while becoming an ion, it always loses electrons first from 4s squared and then 3d6. So basically 4s squared is also always acting before 3d6. And why losing 4s squared before makes the ion more exothermic? Okay, what is the reason behind that? The reason is, losing the 4s electrons first makes, let's say it is becoming from Fe2 plus to Fe3 plus. Okay, so when it is losing 4s electrons first, this makes the ion smaller because there are fewer electron repulsions. Okay, these are actually basic things which I've learned in our chemistry unit 2 and chemistry unit 1 as well. So when this ion is really small, which leads to very high lattice energy, that means stronger ionic bonds. Your ionic bonds will be much stronger when you have high lattice energy. Because the thing is, here you can see, if it had lots, this makes the ion smaller. When you lose electrons from 4s square first, then 3d6, at that time the ions become smaller. Let's say if you draw the shell right here. Okay, if you're drawing the shell, you don't need to remember those small things like lattice energy, hydration, enthalpy. Don't need to remember them. We will again do them in our entropy chapter of chemistry unit 4. Now for the time being, just understand this by easy mean that if someone loses its 4s electron first, then 3d6, this makes the ion smaller. So if the ion is smaller, then at that time, if the ion is smaller, there are less, like, yeah, there are fewer electron repulsions. And as there are fewer electron repulsions in a smaller ion, there are high lattice energy. You don't know about lattice energy right now because we haven't completed entropy till now. When the lattice energy is high, the hydration enthalpy is also more exothermic. Why the hydration enthalpy is more exothermic? Because let's say water molecules can pack more closely around a smaller ion. Around a smaller ion, the water molecules can pack very closely. So these are basically the reasons. Now what I will do is I will provide you guys with all the reasons to your group. Please write them down by yourself. But for the time being, just understand, if the ion is very smaller at that time, the hydration enthalpy is more negative. That means it is more exothermic and the lattice energy will be greater. And these two things are energetically favorable for the reaction. So this is what you guys need to remember for the time being. And if you guys want to know more about lattice energy and exothermic and energetically favorable things, or why it is more exothermic, we'll learn them in our entropy chapter. Done? Does anyone have any problem regarding this part? মৃত্তিকা প্রবলেম হয়েছে আর কোনো? বলেন।
No, sir.
ওকে, জায়দ কোনো প্রবলেম আছে? Okay, what about Amna? Amna, do you have any problem?
No, sir.
Okay, so actually Ajan is going on right here in my area. If Ajan is not going on in your area, please go through these parts from this to this. Come on, quick. These are very easy things that you have actually learned in your unit 1 as well, the successive ionization energies. Bigger jump, nothing else. বলেন। Sure, why not? I have sent the note. Okay, please write them along with your examples. Otherwise, it will be an issue. I think about lattice energy and hydration enthalpy. You have learned them in your chemistry unit 2 as well, right? So it shouldn't have been an issue, but as you guys still have problems, we will read them again. Okay, we will go through them again in our chemistry unit 4 entropy chapter. For the time being, just remember that it is energetically favorable, nothing else, and it makes the ion smaller. If the ion is smaller, then it is energetically favorable. And as the electrons are decreasing, there will be lesser repulsion. Acha. So what they have written is the properties of transition metals. You just need to remember the properties, nothing else. There is nothing to understand here. Forms ion with different oxidation numbers. The transition metals can form ions with different oxidation number. They can form colored ions and colored compounds. We will look at them in the later on this chapter. They can form complex compound with complex ions. This is also we will look after them in our next chapters. They have high boiling and high melting temperatures. This is something that we will not see, but you guys need to remember because the properties might they might ask you the properties. And another thing is that some transition metals and their compounds can act as catalysts. This is very important as well because the catalysts of transition metals we will look at them as well. Now regarding the successive ionization energies of
Sir,
d block elements. Yes, yes. Ask me. Yes.
sir, what do you mean by complex ions?
Achha, the thing is that regarding the complex ions is we will go through the complex ions. We will learn them in detail. If you want to see about the complex ions right now, this is what complex ions look like. This is what complex ion is. A complex consisting of biodentate ligands. We'll go through them in a couple of minutes, okay? We'll go through them. So now regarding successive ionizations of d block elements, what they have said is the energy levels of the 3d and 4s electrons are very similar in d block elements. Yes, the energy level is really similar, but the thing is, as the 4s electrons are lost before 3d electrons, so we can say 3d electrons are lower in energy level, right? The higher energy level electrons are lost before the lower energy levels, right? So the 3d electrons are in a lower energy level than the 4s electrons, but the energy level difference is way smaller. It's very small. So a big jump is always coming after both the 3d and 4s electrons are lost, because the energy level is very small. The bigger energy level difference comes after losing 3d and 4s electrons. When you jump onto, let's say, 3s electrons, from 3s to 3d there is a big jump, but there is not a big jump between 3d and 4s. So when after losing both of these electrons, then a big jump comes. So the big jump comes after all the 4s and 3 electrons have been removed. You can see right here that when the 2 electrons and the third electrons is removed, then a big jump is coming between third and fourth. When the first 2 electrons and the later 8 electrons, first 10 electrons is lost, then a big jump is coming. The first big jump occurs between 10th and 11th after losing both the 3d and 4s electrons. So this is basically what they are talking about. Now let's go through this part. This is extremely important. This is extremely important. What I will do is I will provide you guys with a note, but before that, please let me know whether you guys are clear with oxidation numbers or not. Please let me know, because there are a couple of things in A2 chemistry which I have seen over the years student facing a lot of problems is Hess's cycle, oxidation numbers, and ionic equation. These are a couple of things. These are basic, very basic things which you guys still face problems. So does anyone have any problem regarding oxidation numbers? To বলেন কারো প্রবলেম থাকলে, আর না থাকলেও বলেন। আছে
No,
কারো
sir.
বলেন? জায়ের
No.
প্রবলেম, জায়েদের প্রবলেম নাই অক্সিডেশন নাম্বারে?
Hey,
Okay.
review it still.
Okay, review it still. No, I'm not going to review it. What I will do is I will provide you guys with a recording of mine which I have done before for the A2 students, because they face a lot of problems regarding this stuff and I don't want to review those very basic things in the class. I will provide you guys with a video. Huh?
I have a question. Like each of these transition metals at different oxidation number, they have a different color, right? So do you have to memorize those colors?
ট্রানজিশন মেটালস এর কালারস আপনাকে মেমোরাইজ করতে হবে, বাট এখানের গুলা না, এগুলার কালার গুলো না। এখানে ডিফারেন্ট ক্রাইটেরিয়া আছে। এখানে you can see a different criteria. What you can see right here is from scandium to manganese. From scandium to manganese, we can see that the oxidation numbers are increasing, right? The oxidation numbers are increasing. And from iron to zinc, the oxidation numbers are really low. And another thing that you can see right here is একটু clearly দেখেন সবাই, please look at these things very clearly because it's very important. Another thing that we can notice right here is we have said red ones are more stable than the blue ones, right? The red ones are more stable than the blue ones. Now, from scandium to manganese, the bigger oxidation numbers are the more stable ones. That means the bigger oxidation numbers are the red ones. But from iron to zinc, we can see the lower oxidation numbers are more stable. The lower oxidation numbers are more stable, and from scandium to manganese, the higher oxidation numbers. Let's say here, the bigger one is 4. The fourth oxidation number plus 4 is more stable. Here, the bigger one is between all of them 7. You can also notice that 7 is the more stable one. But here, from iron to zinc, the smaller ones are more stable. They are red colors. Why is that happening? Can anyone explain to me? আচ্ছা, আমি বলি মেইলি ব্যাপারটা কি হচ্ছে এখানে। The thing that is actually happening right here is we know red oxidation states are more stable, right? The red ones are more stable. So what is happening from scandium to manganese is you can see the oxidation states greater than +4. If anyone has oxidation state greater than +4 or at least 4, let's say these ones, they have an oxidation state greater than +4. if anyone has oxidation state greater than plus from, they cannot easily form ionic bonds. They cannot easily form ionic bonds. Why they cannot form easily ionic bonds? Because removing too many electrons requires too much energy. They cannot form ionic bonds because removing too many electrons requires too much energy, because as they have a very high oxidation number, removing their electrons requires a lot of energy. That's why they cannot form ionic bonds. So if someone cannot form ionic bond, what they will form is they will form covalent bonds with highly electronegative elements like oxygen or fluorine. Let's say we can say MnO minus 4. MnO minus 4. So what is the oxidation number of MnO minus 4? কে বলতে পারবা? Anyone?
Sorry ভাই আবার বলুন।
So what is the oxidation number of MnO minus 4? The oxidation number of MnO minus 4 is plus 7. Mn plus 7. Achha. So this is stable. So why it's stable? The reason behind it being stable is this Mn is forming strong covalent bonds. This Mn is forming strong covalent bond with this oxygen. As they are forming strong covalent bond with this oxygen. Now let's say I was talking about this Mn plus 7 till now. I was talking about this one. Now let's talk about Mn. Let's talk about plus 2 or plus 3. These plus 2 or plus 3s are less stable. Why they are less stable? Because they don't benefit from these strong covalent interactions. They don't benefit from these strong covalent interactions. Now I have said a lot of things. Now let's summarize all of the things and let's say all the basic important things. The first thing is from scandium to manganese, we can see elements with higher oxidation numbers are more stable. So why elements with higher oxidation numbers are more stable? If an element has an oxidation number greater than 4 or at least 4, that element cannot form ionic bonds. Because if you have an oxidation number of plus 4, that means your element is really, or your atom is really small, or your ion is really small. If your ion is really small, it takes a lot of energy to remove an electron from that ion. So what basically they do is they form covalent bonds. They cannot anymore form ionic bonds. They will only form covalent bonds. So when they form covalent bonds, the elements with higher oxidation numbers, let's say for manganese, this whole manganese will form higher oxidation number, while they will form oxidation. Why they will form covalent bonds? Because their oxidation numbers plus 7, plus 6, plus 5, plus 4, these 4 ones will form covalent bonds because they have an oxidation number greater than plus 4, and they cannot form ionic bonds because taking out electron from them requires a lot of energy, which is not possible to provide them with. That's why they will form covalent bond. And in the covalent bonds, the bonds are really strong. In the covalent bond, the bonds are really strong, and they support only these elements from plus 4 to plus 7. Now what will happen to this plus 2 and plus 3? As from plus 4 to plus 7, they are forming strong covalent bonds. They are very, very much stable. But what happens to this plus 2 and plus 3? These plus 2 and plus 3, they are less stable. They are less stable because they have lower oxidation states. As they have lower oxidation state, if they form covalent interaction, or if they form covalent bond, their bonding is not that stronger because their oxidation number is really small. So this is what basically happening between scandium to manganese. Does anyone have any problem regarding scandium to manganese? একটু at least বলেন যে yes, I've understood. Please, কারো প্রবলেম থাকলেও বলেন, quick. Hello.
I got it.
হ্যাঁ, বুঝি নাই। হ্যালো হ্যালো, শুনতে কি?
I understood.
ওকে, what about Zad? বুঝছো? Okay, and what about মৃত্তিকা? বুঝা গেছে?
জি ভাইয়া।
Okay, what I will do is I will provide you guys with this note. Huh? This is not that important, but this is very basic. Janata is important. Okay. Now let's talk about from iron to zinc. Why the elements with lower oxidation states are more stable than the elements with the higher oxidation state? What is the reason right here? As you can see, from iron to zinc, they prefer ionic bonding in lower oxidation state. They prefer ionic bonding in lower oxidation state. The reason is they prefer ionic bonding in lower oxidation state. Now let's go through it. The first thing is, as the nuclear charge increases, let's say from +2 to +3, the d electrons will be pulled closer to the nucleus. Let's say this is one subshell, this is the third subshell. If one of the electrons are lost, let's say this is a subshell. Let's think that this is a subshell. Okay, if d electrons are lost, all the d electrons in this subshell are lost, what will happen is now the overall ion has become smaller, right? Now the overall ion has become smaller. So what I'm trying to say is, as nuclear charge increases, the electrons are pulled closer to the nucleus. The electrons are pulled closer to the nucleus. That means the nucleus are becoming smaller. The ion is becoming smaller, making covalent bonding difficult. The covalent bonding is only for the oxidation states greater than +4, +5, +6, +7. Now the covalent bonding has become difficult from iron to zinc because they don't have bigger oxidation states. Now these metals from iron to zinc prefers lower oxidation states, +2, +3, where they can form ionic bonding instead of struggling with covalent interactions. As they have very small oxidation states, they don't wanna struggle with covalent interactions because their covalent interactions will be very weak or not that much stable. So basically they will do ionic bonding. From Fe3 plus is stable while Fe6 plus is unstable. For iron to zinc, we can say Fe3 plus is way more stable than Fe6 plus, because in Fe6 plus for iron, what happens is there does covalent interactions, and in covalent interactions that is not that much stable because the covalent bonding between the irons and the other element, let's say any other element, is not that strong. But for +2 it is way more stronger because it is doing ionic bonding for iron from iron to zinc. So this is basically what is happening. Fe3 plus is stable while Fe6 plus is unstable because it cannot form stable covalent bonds. From iron to zinc, forming a stable covalent bond is way difficult. That's why it sticks with ionic bonding, and for ionic bonding we take these smaller oxidation states. That's why from iron to zinc the smaller oxidation states are more stable, and from scandium to manganese they form strong covalent bonds. That's why the higher oxidation states are way more stable. Acha, so this was quite difficult to understand. Please let me know if anyone have any question. মৃত্তিকা, question আছে নাকি বুঝা গেছে একটু বলেন? হ্যালো জায়েদ, বুঝা গেছে? প্রবলেম থাকলে বলেন।
ভাইয়া একটু from iron to zinc এর oxidation states গুলো lower কেন আবার একটু বুঝিয়ে দিবেন এই পার্টটুকু সামারি?
আচ্ছা জাস্ট আয়রন টু জিঙ্কেরটাই বুঝাবো না, কোথায় জন্য শুধুমাত্র আয়রন আর জিঙ্ক। আচ্ছা,
Yeah.
So basically from iron to zinc, if the nuclear charge increases, let's say if the nuclear charge increases, let's say from +1 to +3, sorry, +1 to +2 or +3, if the nuclear charge increases, the d electrons will be pulled closer to the nucleus, right? If the nuclear charge increases, if you lose more electrons, the d electrons will be moved closer to the nucleus, making covalent bonding difficult. Because for be able to do covalent bonding, what you need is you need higher oxidation states, but here the oxidation states are way smaller. Okay, here the oxidation states are smaller, only +2 +3. Now it becomes it makes the covalent bonding difficult. Now, from iron to zinc, what these metals prefer is they prefer ionic bonding for the oxidation states of +2 and +3. So when they do ionic bonding for +2, +3, rather than weaker covalent bonding of +6, +5, the ionic bondings in +2 and +3 are way more stronger and more stable. This is the main important thing. So basically, I'm going to explain both of them again. The first thing is from scandium, from scandium to manganese, the higher oxidation states are more stable because the higher oxidation states does covalent bonding, and that covalent bonding is really strong rather than the ionic bonding of +2 and +3. Or actually they cannot actually do ionic bonding. They actually cannot do ionic bonding. From scandium to manganese, they cannot do ionic bonding. Okay, because they have an oxidation states of +4. If someone has an oxidation state greater than +4, they cannot undergo ionic bonding anymore. Okay, because removing those electrons requires a lot of energy. This is the first thing. Now the second thing is, as they cannot do ionic bonding, these +4, +5, +6, হ্যাঁ হ্যাঁ বুঝি নাই কি বললা? হ্যালো, আরেকবার। হ্যালো। আচ্ছা, আমার নেটের সমস্যা, তোমাদের নেটের সমস্যা, আমি বুঝতেছি না। আরেকবার বলো। হ্যাঁ হ্যাঁ, আরেকবার বলো তো।
আপনারটা মনে হয় একটু ল্যাগ
হ্যাঁ হ্যাঁ
করতেছে।
হ্যাঁ হ্যাঁ,
Plus
বলেন বলেন।
যেহেতু scandium, so it won't form a covalent bond.
Regarding scandium, yeah, it will still form a covalent bond because from scandium to manganese, আমাদের এই নোটে হয়তো ওগুলো দেয়া নাই, বাট ইট ক্যান ফর্ম কোভালেন্ট বন্ড, কারণ ওর +4 +5 ও করতে পারে। বাট হয়তো এই নোটটাতে তোমাদের বইয়ের যেই এই পার্টটাতে আছে অথবা বইয়ের এই পার্টটাতে দেন, বাট ইট উইল বি এবল টু ফর্ম, নট অ্যান ইস্যু। ও ফর্ম করতে পারবে, ঠিক আছে। আচ্ছা, এখন আসেন, বাকি সবগুলো হয়তো আবার দেয় নাই ওরা। আচ্ছা, from scandium to manganese, as they have the oxidation state greater than +4, it will not form ionic bonds, because forming ionic bonds requires a lot of energy to be removed when someone has an oxidation state of +4. But for them, they can form ionic bonding because they don't have an oxidation state of +4. Clear? এতটুকু পর্যন্ত জানা আছে। আচ্ছা, the next thing is, as from scandium to manganese, these metals will form covalent bond, and the covalent bond will be really stronger. Now, for +4, +5, +6, +7, their covalent bonding will be really small, but really strong. But for +2 and +3, as they have very small oxidation states, their covalent bonding will not be that strong. So as their covalent bond will be not that strong, that's why they are less stable than these ones. You can also see in this V, the +3 is also stronger. But why? This will be actually explained in a very greater amount, যেটা আমাদের সিলেবাসে এত ডেপথে নাই। আপনি আমার জিজ্ঞাসা করতে পারেন, ভাই আপনি তো এতক্ষণ বললেন শুধুমাত্র +4, +5, +6, +7 স্ট্রঙ্গার কোভালেন্ট বন্ডিং ফর্ম করতে পারে, তাদের স্টেবল বেশি। এখানে তো দেখতেছি +3ও স্টেবল। থিং ইজ, আমাদের এত ডেপথে যা শিখতে হবে না, আপনাদের জাস্ট একটা জিনিস জানতে হবে, from scandium to manganese, they prefer covalent bonding because oxidation states greater than +4 prefers covalent bonding than ionic bonding, because doing ionic bonding requires a lot of energy to be removed, to be provided to remove an electron. This is the part. Now, from iron to zinc, they prefer ionic bonding. So as they prefer ionic bonding, oxidation states lower oxidation states are more stable. This is the main thing, nothing else. Clear? এটা এত একটা ইম্পর্টেন্টও না যে we have wasted around 10 minutes just understanding them. It will arise a lot of questions, but in your syllabus those questions doesn't need to be answered. Okay, just এই দুটো জিনিস মাথায় রাখলেই হবে, nothing else. Clear? So does anyone have any question? বলেন, স্টিল কারো কোনো কোয়েশ্চেন থাকলে একটু বলেন প্লিজ। আছে কারো কোনো কোয়েশ্চেন?
No.
ওকে, আচ্ছা, আমি প্রোভাইডিং দ্য নোট। হ্যাঁ, আমি একটু নোটটা পাঠাচ্ছি, আমার আগের ইয়াতে ছিল, আমি একটু নোটটা ডাউনলোড করে বের করে দিচ্ছি। একটা মিনিট লাইনে থাকে না দাদা, একটা মিনিট লাইনে থাকে না। A2 chemistry, May 2025. Acha, please go through this note right now, quick, and ask me if anyone have any question. Come on, quick, guys. Please go through this. Chemistry Unit 5 is really difficult. This is one of the most difficult units in the whole A levels. So make sure you're understanding everything in detail. Otherwise, it will be a big deal later on. সবাই go through করেন একটু. I've explained everything in detail there. Please write these notes in your copy. Otherwise, before the exam day, you won't be able to figure that out or find that out in the group. So make sure you're doing this. Now for the hydroxides of transition metal cation. Now we will be moving to the transition metal cations. Nitika, তুমি কি নোটস গুলো দেখছো? হ্যালো,
Yes, sir.
কই তুমি তো সিনই করো না এখনো। নোটটা পড়ো, পরে আমার
Team করছি।
আচ্ছা ঠিক আছে। Okay, so can you guys hear me right now? I've changed the network. Acha. Now let's start again. So basically we are done with this part. Now let's move forward to the ligand, and then we will again come back to this. So before going through the ligands, what we have to do is, okay, these are deep protonations. We will do them later. Okay, now let's go through these monodentate ligands, biodentate ligands, and coordination numbers. Ligands, complex ions. Okay. And dentate ligands and effects of ligands on color. Okay, so this is basically what we have. Now, let's go through this part, okay? Ligands. Now we will go through the ligands. Please go through this. Come on, quick. And then we will finish them together. Come on, guys, quick. Amna, do you have any question regarding that scandium to manganese and from iron to zinc? Amna?
No, sir.
Are you completely done with this part?
Yeah.
Achha, I'm asking again and again. If anyone have any question, ask me. Please don't hesitate. And now let's go through this. If none of you guys have any problem, then go through this. Ziad, তুমি বুঝছো? Okay, এখন এটা পড়েন দ্রুত. We will try to complete the whole transition metal today. যদি possible হয়, অথবা we will complete it in our next class. Then we'll be done with 2 difficult chapters of chemistry unit 5. And then we will do a combination of transition metals and electrode potential. Next 2 class, we'll be done with 60 to 70% of chemistry unit 5. Quick, guys. Let me know when you guys are done reading it.
আমাদের রিডক্সের এক্সাম কখন হবে?
Redox exam na. I wanted to take the Redox exam after 1 hour's class of today, but actually maybe I won't be able to take this exam today because I want to complete the ligands part today as well. But inshallah, in our next class we'll be taking an exam on redox, okay, on our redox chemistry.
Okay.
Or either I will take that after completing the whole redox chapter because we are left with another 40 or 45% of that chapter. Now please go through this. Okay guys, so let's start these complex ions and complex compounds. আপনারা সবাই চুপ করে থাকেন, মানে কেউ পড়া হইলেও বলেন না, বুঝলাম না আসলে, না বুঝলেও বলেন না, এত চুপ থাকলে হবে? কথা তো বলতে হবে। Okay, so now let's start complex ions and complex compounds. So what they have said in the complex ions and complex compound is, let's say this is a complex ion. Okay, this is a complex ion. So it is an ion or a compound. This complex ion can be an ion as well. Let's say this is an ion, right? It is +2 charge. Now, in which molecules or ions, which are ligands? These are ligands. These are ligands. They will form dative covalent bond. With whom? They will form dative covalent bond with the central atom or ion. So this is our central atom with which they are forming dative covalent bond. This is the dative covalent bond. In this part, they are forming the dative covalent bond. Okay. A ligand will form dative covalent bond with the central metal atom or ion. A complex can either be positively charged, negatively charged, or neutral. As this is a positively charged, this is a positively charged example. But in the next part, you will also see how a negatively charged ligand can act like as well. Basically, we didn't give an example like this, but yeah, it will have a negatively charged dative covalent bond, negatively charged complex ions or compounds. Okay. Now let's go through this coordination number. The coordination number means it is the number of dative covalent bond bonded to the central ion. So for this, let's say for this copper, it has formed dative covalent bond with how many ligands? It has formed dative covalent bond with 1, 2, 3, 4, 5, 6. So it has a coordination number of 6. Done. Now let's talk about the ligands. Ligands are ions or molecules which forms dative covalent bond with the central atom or ion in a complex is known as a ligand. A ligand can either be negative or neutral. Let's say for here is some water, so it's neutral. So now let's move forward. Now let's go through this monodentate ligand. In the monodentate ligand, one atom in a molecular ion forms dative covalent bond with the central atom. One atom in a molecular ion forms dative covalent bond with the central atom. Let's say for OH2, out of this OH2, only one atom in this OH2 molecules are forming the dative covalent bond with the central atom. Let's say for copper. Okay. Only one atom is forming the dative covalent bond. Let's say for OH2, NH3, OH minus. These are one of the examples. Now, for biodentate ligands, what you guys can see right here is this is ethane dioide ion and 1,2-diaminoethane. So what actually happens right here is, you can see in biodentate ligands, as the name suggests, the two atoms of the ligand will form a dative covalent bond with the central metal atom or ion. So out of this whole ligand, these two atoms are forming dative covalent bonds with the central atom or ion. So this is basically what biodentate ligands mean. Now, as the name suggests, in the hexadentate ligand, 6 metal atom or ion will form dative covalent bond with the metal ion. Okay, this is up to what which you guys need to know, nothing else. So please ask me if anyone have any question. Come on. Anyone
Sir,
with
what
any
is the significance of the
question?
arrows?
বুঝি নাই আরেকবার। Which one? আরেকবার।
First one টা কি ছিল?
First one কোনটা? শুধুমাত্র monodentate ligands?
হ্যাঁ।
এই যে একটা অ্যাটমের একটা মলিকুলার একটা অ্যাটম শুধুমাত্র dative covalent bond form করতেছে with the central atom. Biodentate দুইটা অ্যাটম, সরি একটা লিগ্যান্ডে দুইটা অ্যাটম ফর্ম করতেছে, আর হেক্সাডেন্টাল লিগ্যান্ডে পুরো একটা ইয়ার 6টা অ্যাটম মিলা ফর্ম করবে। ঠিক আছে, এখানে আবার দেখেন দুইটা করে আছে, কাহিনী আছে এর মধ্যে। এটা আপনাদের জানা লাগবে না। দিস হেক্সাডেন্টাল লিগ্যান্ডস এর যে এক্সাম্পলটা আছে, you don't need to know this actually. For high impact crash course, you actually don't need to know this because এটা জীবনে এক্সামে আসবে না. It will never ever arrive in your exam. হ্যাঁ, so you don't need to know these things. Actually biodentate ligands, monodentate ligands, hexadentate ligands, এটা জাস্ট এই টাইপের জিনিসগুলোই আসে, nothing else. So let me know if anyone have any question. Amna, you had a question, I think, right?
Yes, for biodentate ligands, why is the shape curved? Like, can't you write the 1,2-diamines in a straight chain?
1,2-diamine ethane in a straight chain. So what will happen if I draw them in a straight chain? It will nothing will happen, right? I haven't drawn it in a straight chain right here, right? I haven't drawn it in a straight chain.
Yes.
This is actually what is happening. If I have drawn ethane diode ion, I would have drawn like this, and then I would have just connected two of the atoms with the central atom, nothing else. You can also draw it in a straight chain as well and then connect both of them with the central atom. This is not an issue whether you are drawing it in a straight chain or in a curved chain, or they are cyclic compounds or anything else. That doesn't matter.
Okay, sir.
Now let's move forward. Here what I have attached is an example of coordination number and the oxidation number. Please go through these parts. These are important. Okay, as none of you guys have any problem regarding oxidation numbers, so it won't be an issue for you guys. But still, if you face any problem, go through the YouTube channel of mine. You will find a video regarding oxidation number, or if you don't find, then ask me. I will provide you guys with that. Okay. Achha. So basically, this is what an example of hexadentate ligands is. But it's quite difficult to make you guys understand through this. It requires a simulation. Otherwise, it's difficult to understand how the 6 atoms of a ligand is forming dative covalent bond with the central metal atom or ion. So basically, making you guys understand while drawing is very difficult, and it requires a simulation. I'm not gonna waste 5 or 10 minutes by showing that simulation. Now let's understand the effect of ligands on color. Okay, let's understand the effect of ligands on color. Mritika, আপাতত কোনো question আছে?
No, sir.
Okay, ঠিক আছে, excellent. আচ্ছা, পড়ান আপনারা। Come on, quick. Come on, quick. And ask me questions. Coordination number, shapes of complexes, linear, tetrahedral.
Sir, how is NH3 a stronger ligand?
Why is NH3 a stronger ligand? Okay, I will make you understand. তুমি আমারে at 9 PM কল দিও, হ্যাঁ? আমি এখন একটু ক্লাসে আছি, ঠিক 9টা বাজে কল দিও। Okay, so none of you guys have any question? Just you guys have one question, which is why NH3 is a... আচ্ছা, একটা মিনিট। Hello. Yes, sorry for the delay. Actually, my Wi-Fi operator came because the network has been an issue for the last couple of days. Acha. So someone asked why NH3 is a stronger ligand than um, the H2O, right? So Amna, please let me know which is more electronegative, nitrogen or or oxygen. Let's say oxygen or nitrogen. Which one is more electronegative? Amna, which one is more negative, electronegative? Hydrogen, nitrogen or oxygen? Hello, Amna. Can you hear me? হ্যালো, আচ্ছা মৃত্তিকা তুমি শুনতেছো? কেউ কি শুনতেছে না? রাইসা তুমি শুনতেছো?
জি ভাইয়া, আমি বুঝছি।
আচ্ছা না না বুঝছেন না, আপনি আমার কথা শুনতেছেন নাকি এটা বলেন।
ও হ্যাঁ, এখন শুনতে পাচ্ছি। সরি, আমি একটু ওইদিকে যাইতে হয়েছিল আমার। এখন শুনতেছি,
আচ্ছা
আমি আসছি এখন।
আচ্ছা আমনা, ক্যান ইউ হিয়ার মি?
Yes, I can.
Okay. So please let me know which one is more electronegative, hydrogen or nitrogen or oxygen?
Nitrogen?
Oxygen.
No. Yes. Actually, nitrogen is less electronegative than oxygen. So yeah, oxygen is more electronegative. So as nitrogen is less electronegative, so allowing NH3 to donate electron is more easy. Okay, so that's why as it loses electrons more easily, so it is a stronger ligand. We can say NH3 is a stronger ligand because nitrogen is less electronegative than oxygen, which allows NH3 to donate electrons more easily. So as NH3 can donate electrons more easily, so it's a stronger ligand. Now, it also causes greater d orbital splitting, that I have written right here. Why it causes stronger d orbital splitting? Because it is less electronegative than oxygen and it can donate electrons more easily. Now, which leads to stronger metal ligand interactions. If you connect stronger ligand, you get stronger metal ligand interactions. And NH3 complexes are more stable than H2O complexes in transition metal. Clear? In transition metal, NH3 complexes are more stable than H2O. That's why a stronger NH3 has replaced a weaker ligand. So please let me know if anyone have any problem. ঠিক আছে, একটু জানান আমারে কারণ কোনো প্রবলেম আছে? আচ্ছা, so I'm assuming that none of you guys have any problem. So basically what it is happening right here is effects of ligands on color. Let's go through this part together. What is actually happening right here is a stronger ligand splits the d orbital in the complex ion to a greater extent than a weaker ligand. So blue and yes, showing relatively weaker ligand H2 are replaced by stronger NH3 ligands. The absorption moves from orange towards yellow. So it is moving from orange to yellow. So the color will change from blue to violet blue. Okay. Relatively weaker ligands H2 are replaced by stronger NH3 ligands. The absorption, yes. Now, effect of oxidation number on the transition metal ion. An ion with a high charge density, if the oxidation number is high, it will have a higher charge density, will attract a ligand strongly. If you have high charge density, you will attract the ligand more strongly. If the ligand and metal ion bonding is stronger, then the splitting of the d orbitals will be greater. Now, effect of change in coordination number on color. If the coordination number changes, the color will shift. You just need to understand this, nothing else. You don't need to understand if the coordination number increases, what will the color? If the coordination number decreases, what will the color? No, you don't need to understand that. You just need to understand that if the coordination number changes, the color will also change, nothing else. And this is important. The stronger the ligand, the more the color absorption and the more the color shifts anti-clockwise. So this is shifting in this direction. Thus observed color shifts anti-clockwise. The color that is observed, the color opposite to that is seen. So for if orange color is observed, the blue color will be seen. For this one, for this. Okay. It will also shift in this direction. The uh, the observed and the observed color. If the observed color is yellow, the observed sorry, if the observed color is orange, then the if the observed color is orange, then the seen color will be blue. If the observed color shifts from orange to this yellow one, it will shift from blue to the violet blue. Okay. So basically this note
স্যার কালার শিফটিংটা বুঝিনি
কোনটা 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 কালার
Colour
চেঞ্জিং
তো হ্যাঁ
আচ্ছা 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 বুঝেছি, বুঝেছি, বুঝেছি। So what actually they are saying is it will shift to the left. Huh? The stronger the ligand, it will it will shift anti-clockwise. We know this is anti-clockwise, right? And this is clockwise. So if you move from a weaker ligand to a stronger ligand, just like from water to NH3, it will replace NH3. Sorry, NH3 will replace H2O. So a stronger ligand will form bond, right? So if a stronger ligand forms bond, it shifts colors in the anti-clockwise direction. Let's say for H2 it was in this direction. If it is H2 in this direction, if the absorption is orange, then the color you will see is blue. Okay, the color you will see is blue. Now if you replace H2O with NH3 with a stronger ligand, it will shift anti-clockwise and it will become this yellow. If the color shifts in the anti-clockwise direction, this will also shift anti-clockwise. So from blue it will become violet blue. Clear ever bolan any guys?
যদি H2টাকে রিপ্লেস করি তাহলে হবে হচ্ছে অরেঞ্জ টু ইয়েলো
হ্যাঁ আপনারা এটা মেমোরাইজ করতে, you don't need to memorize it like this from H2O to NH3. The thing is, if you replace a weaker ligand by a stronger ligand, it will shift anti-clockwise. So as it is shifting anti-clockwise in the absorption part, it will also shift anti-clockwise in the seen part as well. ঠিক আছে, the color you will see. এবার ক্লিয়ার বলেন নাকি প্রবলেম আছে? থাকলে বলেন। ক্লিয়ার?
ইয়েস ক্লিয়ার
ওকে, একটা মিনিট লাইনে থাকেন, আমি একটা এক্সট্রা নোট পাঠাচ্ছি, দেন ওটা একটু বুঝাবো। হ্যাঁ, একটা মিনিট। Okay, this is important. যাবে এদিকে। Chemistry 1 note. জাহেদ কি আছে? জাহেদ তুমি আছো এখনো? ওকে, থাইকো থাইকো, তুমি গিয়েও না, তুমি গেলে কিন্তু রেকর্ডিং অফ হয়ে যাবে। I will be in big trouble. যাও না। Now we will go through this note. এখানে কিছু extra informations আছে। I didn't complete entropy chapter yet, that's why I didn't use this note. But we will complete entropy later on together. We will complete them together. Don't worry. A minute. So effect of change in temperature, del S, del S system, del S surrounding. Yes. Here it is. এর আগে একটা জিনিস ছিল which we didn't study yet. Okay, এখানে bond Haber cycle আছে. We will go through the bond Haber cycles again. Okay, so basically this is what I wanted to make you guys understand. Huh? Please take a screenshot of this note. Please take a screenshot of this note and write it on your own in your copy. Huh? So what I am trying to make you guys understand is, please read this part and go through this note part as well. These two things are important, nothing else. Huh? To go through current, please come on, quick. আমার জানান। Okay, so basically what they're trying to say is, in an isolated metal atom or ion, basically what we have seen previously was later part of this note. This is the first part, and the ones that we have seen previously is the second part. So I have shown you the second part before, because understanding the second part makes understanding the first part more easier. This is like reading the books of class 10 before reading the book of class 9. Okay. So in an isolated metal atom or ion, the 5d orbitals are degenerate. Degenerate means they are at the same energy level. You can see right here. All of them are at the same energy level. Okay. This is the origin of color in transition metal ion. We have seen the origin of color, right? So how does the origin of color comes? The origin of color means in a degenerate, in an isolated metal atoms, the d orbitals are degenerate. The 5d orbitals are, all of them are degenerate. But when they enters in a complex ion, the d orbitals differ slightly in energy levels. Why does they differ? Because of overlapping of differently with ligands. Overlapping differently with ligands. Now the d orbitals overlap with the ligands differently. Let's say for the metal ion. Okay, the metal atom forms additive covalent bond with the ligands, right? So now it has, in a complex ion, this metal atom will have the d orbitals of this metal atom will have different energy levels. Why? Because they will overlap in a different way to what they previously overlapped with the ligands. So d orbitals becomes non-degenerate. So how they become non-degenerate? Some of the electrons move higher shell and some of the electrons move lower shell. So what is happening? Electrons move from the lower energy d orbitals to higher energy d orbitals by absorbing energy from the light. So it will, a light will come right here. So what will happen is these d orbitals will move to the higher energy levels. It will move up. Okay, it will move up. Degenerate means splitting of d orbitals. It will move up by accepting energy from the sunlight or light. And if the frequency of the light absorbed in those energy transitions is in the visible region, only then ions appears colored. We have seen the transition metal atom to be colored, right? I think the water was orange color, right? So it was colored because the frequency of light which it um, absorbed was in the visible region. That's why that transition metal appeared as a colored transition metal. The color of the ion is complementary to the colors absorbed. We have understood that complementary, right? The color that you will absorb is the opposite color that you will see in that circle. So does anyone have any question regarding this part, guys? Zed, question আছে? Zed, question নাই. Amna, do you have any question?
No, sir.
Mritika, question আছে?
No, sir.
আচ্ছা, ঠিক আছে. Very good. As you guys don't have any more questions, let's go through these two parts as well. The linear, tetrahedral, and octahedral coordination, sorry, complexes. Poren, huh? Poren. Coordination number 6, coordination number 4, coordination number 2. I don't think anyone will have any problem regarding this because this is child stuff. Still to Poren. Guys, let me know if anyone have any question. জায়দ পুরোটা বুঝা গেছে পড়া বলেন। ওকে ওকে পড়েন পড়েন।
Done, sir.
Okay. So I'm assuming that none of you guys have any question. So basically I missed yesterday's class, that's why I'm taking an extra class today of 1 hour. Acha, we're done with biodentate ligands, hexadentate ligands. Now let's go through this part. একটু এটা পড়েন দেখি আপনারা কতটুকু বুঝেন। Come on. Amna, do you have any problem up to now? Amna?
No, sir.
Okay, very good. Okay, so basically what we have seen in the previous part is that they have variable oxidation states, right? We have seen before that they have variable oxidation states. Here, they had variable oxidation states. So why is the reason behind having variable oxidation states? Now we will learn them together. Here, bhai. Huh. Huh. So please go through this. Come on, quick. Come on, guys. I have make you guys understood one of the parts in the previous part as well. So make sure you are understanding them in detail. Come on, quick. মৃত্তিকা ফিজিক্সের ওই তিনটা ভিডিও কি দেখা হইছে? সার্কুলার মোশনেরটা দেখা হইছে মৃত্তিকা?
হ্যাঁ, momentum আর circular motion done.
মোমেন্টাম এন্ড সার্কুলার মোশন। ওকে, ওগুলো কি সব বুঝা গেছে নাকি কোশ্চেনস আছে?
না, আমার কোনো question নেই।
আচ্ছা, still we will go through them in our next class because October 25 এর ব্যাচ তো স্টার্ট।
আগের ক্লাসে কি করানো হয়েছিল?
হ্যাঁ বুঝে নাই, কি বললেন?
আগের ক্লাসে কি করানো হয়েছিল?
আচ্ছা, আগের ক্লাসটা নিতেই পারি নাই জাস্ট বিকজ ওই দিনে অনেকজন জয়েন করে নাই। ওই দিন মেবি বিপিএল এর ফাইনাল ছিল তো সবাই খেলা দেখতে চলে গেছে।
না, you said unit 5 এর একটা ক্লাস হয়েছে মনে হয়।
ইউনিট 5 এর তো কেমিস্ট্রির হয়েছে, ফিজিক্স এর না। যে এখনই তো ইউনিট 5
কেমিস্ট্রির কথা বলতেছি আমি।
আচ্ছা, লাস্ট ক্লাসে ইলেকট্রোড পটেনশিয়াল পড়াইছিলাম, ওটা পুরোটা শেষ করে ফেলছিলাম। আমি তোমার নোটটা প্রোভাইড করে দিব, তুমি পুরো নোটটা গো থ্রু করবে।
রেকর্ডিংটা আছে?
রেকর্ডিং ওদিন করি নাই বিকজ none of them asked me for the recording. But still যদি তোমার ইস্যুস থাকে I will take a separate class for you, on electrode potential inshallah. ঠিক আছে?
Thank you.
And another thing is that for all of you guys, as you guys have your exams, as most of you guys have your exam on May 25, right? Raisa and Nazifa, both of you guys have your exam on May 25, right?
Yes.
So what I will do basically is I will provide you guys with an organic chemistry video of chemistry unit 4. I'm not going to teach you using the recordings. What I will do is I will provide you with the recording. I have provided them to Zad as well. So what you guys will do is watch those videos and study the notes before our class. And in the class, what I will do is I will explain them in detail to you guys so that you guys can have a better explanation and ask me more questions in the class before, just because you'll be done with the notes and the video before the class. ठीक है sir? Your preparation will be much better and we will be able to complete the syllabus in a shorter time. Ready?
Okay.
So these are the small ways that we will follow. And for Mythic, as you will be completing in October 25, you will get this syllabus done twice. And we will do the question papers and exams with them as well. So we will be prepared way before the new exam. আচ্ছা, সো আমরা কি কেউ বুঝতে পারবেন প্রথম দুইটা প্যারা? কেউ কি বুঝছেন বলেন? Amna, did you understand this page completely?
Yes, sir.
Okay, we have understood it completely. And what about the others? আপনারা সবাই বুঝছেন? This is basically the note which I have sent you guys in Messenger. That note is not that this note is not that detailed, but that note is in detail. Okay, so but still I'm going to make you guys understand. So why there is a variable oxidation state? So the reason for having variable oxidation states is, let's say when iron 2 plus transfers to iron 3 plus by losing an electron, its charge increases and the radius decreases. But to transform iron 2 plus into iron 3 plus, you need to provide an extra energy to remove the electron, right? To make its charge increase and radius decrease, and it to convert from iron 2 plus to iron 3 plus, you need to provide energy to bring that electron out of that iron 2 plus and make it iron 3 plus. So you are providing an extra energy. So as you are providing an extra energy, you will also regain that extra energy. So how you will regain that extra energy? You will regain that extra energy because when this iron 3 plus will form stronger ionic bonding with the water at that time, this energy will be regained. Clear? This energy will be regained, the energy that you have provided while removing that electron. But when you when it makes ionic bonding with other water, at that time the energies will be regained. So that's why they have a variable oxidation state. And the reason for variable oxidation state is because the successive ionization energies increases steadily. Successive ionization energy doesn't increase at a very high speed. It increases steadily. Okay. Now, this
How
is
will
the
they gain energy?
How will they gain energy? This iron 3 plus is forming ionic bonding with water. So water is providing him some energies. That's how he's regaining the energy. Clear?
Water is providing the energy.
Ionic bonding form করলেই তো you are sharing the electrons, right? So at that
Yes.
time you are at least getting some energies. ব্যাপারটা তো এরকমই, তাই না?
Okay.
The thing is you are losing an electron right here. You are losing an electron. That's why you're becoming iron 2 plus to iron 3 plus. You have lost an electron. So let's say you have lost energy as well, or energy should have been given to you. Okay? Now, as you have transferred from iron 2 plus to iron 3 plus, energy was needed to provide to you so that you can lose that electron, or that electron can be taken away from you. Now, you are provided with electrons when you have bonded with ionic bonding with water. So when you are bonding with ionic water, you are again having more electrons in your shell.